In this video we are going to look at stationary points and we're going to talk about how we classify stationary points. I just want to remind you about a normal graph. So this is particularly a quadratic graph. Let's look at the gradient around the minimum point here. So if we're looking at the gradient from the left of this minimum point, we can see that the gradient is negative. As we move from left to right, we then get to the minimum point. Now at this point, for a moment, the gradient is 0. Then if we look to the right, the gradient then goes positive. Remember that when we differentiate a function, that gives us the gradient of this function at any point x on the graph. Let's have a look at algebraically how we discover whether the gradient is positive, negative or 0. So I've got a couple of examples here. So y equals 2x squared plus 3x. Let's differentiate to find the gradient function. And I get 4x plus 3. Now if I substitute x equals 1 into this gradient function, I find the gradient at the point when x equals 1. So working that out, I find that the gradient is 7. This is a positive number. So at the point when x equals 1, I've got a positive number. Alright, let's look at a different case. F of x equals 3x squared plus 4. Let's differentiate. 3 times 2 is 6, so the gradient function is 6x. Now let's find the gradient at the point when x equals negative 2. So substituting x equals negative 2 into my function, I get the gradient at the point x equals 2 is negative 12. So we can identify that this is a negative gradient. Let's look at a different case. When I differentiate this function, I get 3x squared plus 12x minus 15. If I substitute when x equals negative 5 into this function, I get 3 squared 25 times the 3 plus negative 60 minus 15. I get the answer to be 0. This tells us that at the point when x equals negative 5, the gradient is 0. When we find a 0 gradient, that means there's a stationary point. Now there are 4 types of stationary points of which we have met 2 before. Let's just have a look at the first type of stationary point. We call this a local maximum. So looking at this particular graph, we can see there's a maximum point. Let's look at how we identify without the graph how we would find a maximum. What we do is once we've discovered where the point, where the gradient is 0, we look at the gradient either side of that. So we're going to look to the left and to the right. Now in the local maximum case, the gradient to the left will be positive and the gradient to the right will be negative. You can see in green I've written here the function note, or just the notation that revolves around that. In other words, when x, so at the maximum exists here when x equals a. And you can see if x equals a, then f dash of x equals 0. That means when x equals a, the gradient is 0, therefore there is a stationary point occurring. So when x is less than a, in other words to the left, the gradient is greater than 0. We have a positive gradient. And when x is greater than 0, that means we're looking to the right. Sorry, that should be when x is greater than a, not 0. That's an error. X is greater than a, so we're looking to the right of a. We can see that the gradient is less than 0. In other words, it's a negative. And when that happens, we classify that as a local maximum. Now let's look at the local minimum. So if we've identified that we've found the gradient is 0, let's look to the left and to the right. If we look to the left of a local minimum, we find that the gradient is negative. If we look to the right of the local minimum, we find that the gradient is positive. We would classify that scenario here as a local minimum. Let's meet 2 new stationary points. The first one we call a positive stationary point of horizontal inflection. Most of you will understand this is a cubic graph. And at this point, for a moment, the gradient is 0. And to identify this, we'd look to the left and to the right of where we found the gradient as 0. To the left, we have a positive gradient. And to the right, we also have a positive gradient. So in this case, we would classify that as a positive stationary point of inflection. The last kind of stationary point is a negative stationary point of inflection. Now let's look at that. To the left of where we found the 0 gradient, we have a negative gradient. And to the right, we also have a negative gradient. A stationary point or a turning point is a point on the graph where the function momentarily stops rising or falling. That is, it's a point where the gradient is 0. Remember, if we have the function f of x, if it has a stationary point, we will know that by differentiating and discovering the point at where the gradient equals 0.